and our responses, particularly in the light of freshwater and carbon. And that's fantastic and essential, of course, but it's very easy to lose sight of a couple of things. One is that people need to be able to farm profitably, they need to be able to farm productively, and they need to be able to fit farm systems to the land and the climate and the people in a way that provides the best outcomes. And that is, and this is where I'm heading, that is a complex jigsaw puzzle. Right? It's not easy to kind of say how do we fit a farm system best to the land and everything else that goes around that. And it's very easy in today's world of sort of 20-second sound bites to look for what's the silver bullet. Oh, we just feed our cattle seaweed and we'll be right, or whatever else it might be. And we know that farm systems are complex, they have feedback loops, it's not that simple. And today we have some people in the room who have some fantastic experience and some learnings from working through farm systems in both a research and a practical way. So we're very excited to hear from those people. I'm going to invite Graham Ogle to come up now, and Graham's going to jump up and down during the day introducing people. I guess Graham has done a lot of work in recent weeks working with many of you, organising today, and on behalf of Rezare Systems, we're very grateful for that work as well. Thanks, Graham.
Thank you, Andrew. Rezare's been planning to run this workshop for quite some time, and it's a real pleasure to have a room full of all the people we want here for this workshop. What I want to do is just cover why we're running the workshop and a little bit about how. I think this is a chance for... Rezare's been looking for the chance to have a bit of a, and I found the word the other day, a policy refresh, a strategy refresh, sorry. Very cool word. And we thought, what better way is there to have a strategy refresh than invite all the right people, and we think you're all the right people, to a venue and talk about what we see as really valuable to farmers. What is value? What is value when we say, of all the things we can provide a farmer, what are the valuable things? I guess I started my career, my idea of that really was forged out of when I started my career in the 1980s, which meant that I had 2 decades of excruciatingly low product prices to work with for farmers. I remember sitting with a farmer one day, he was in trouble, the farm was going to get sold up, and I thought, if we get $35 a lamb, you'd be right. And of course, the markets weren't delivering that. Now, you can adjust that by whatever you like, whatever inflation index you like. The CPI would mean that farmers today would be getting $55 a lamb. And I imagine our budgeting would be even more difficult today given the increase in costs. Dairy farmers were getting $2.40 a kilo of milk solids. I mean, it's almost unheard of. And if we ramp that up by the CPI, we'd be talking about a payout today of $3.70. So this was a sort of the anvil that forged my early career, and going out to do things for farmers that were of value. The biggest value we could do for farmers then was increase their profitability, and that started to address all the other problems that were on the farm. So when Rezare set out, as we did in 2004, as a group dedicated to agricultural software development, often we sit around and think, is our strategy aligned with where the value is in the industry? Are we aligning our investment in resources where the value resides in the industry? So what we're going to do today is we're going to think, how might we align our investment with what top farmers are saying is important to them? And I can't think of any better way to start this workshop than listening to some top farmers. So that's what we're doing. I think consulting is also an extension of farming, and we'll listen to consultants after that. The farmers that we'll listen to have been through some process of change or intensive planning. And it's from those discussions that we hope you'll pick up some things about what they value. And maybe a successful outcome of this workshop is if you go home and think, hey, maybe we need a strategy refresh as well. So we're going to start off with Linda Lilburne. I think it was 16 years ago I met you first time, back in Landcare Research, when I worked for Landcare Research, which I recall was a good organisation to work for, always short on money. What I'm hoping I'm going to hear from you, Linda, is that you're working in an area of reanalysing the fundamental soils layer into S-maps, and I imagine that takes a bit of work. What could be more fundamental for everyone here than the soils on the farms they're working with? I'm hoping I'm going to hear from you, Linda, that you're massively well resourced and you couldn't be doing it faster, because I'm really looking forward to the results. Thank you, Linda.
Hopefully someone will find me my presentation. Is it there? Oh, it's there. Fine, cool. So I made two assumptions when I was putting together my presentation. The first one is that everyone here would believe that soil was really important and that it had lots of value. And so I've got no slides on that. I'm just leaping straight into the information. But I'm a little bit worried that I might have got it wrong, because only, I think, 3 people mentioned the word soil this morning. So that's kind of interesting. And the second assumption I made was that I should just talk about the soil and the land. And in fact, Manaaki Whenua does do other work, remote sensing, proximal sensing of things like land cover, vegetation and so on. But I'm not talking about that. I'm just talking about the fact that our role is that we are the national custodian of those soil and land related data sets. And I thought I'd just describe what some of these key ones are. The first is the NSDR, National Soils Data Repository. I think of that as being point data. So it's not spatial, it's just point data. It might actually be a few points that get bulked together, but essentially it is point data. Usually that's been sent off to the lab, and so there's analytical data with that. Might be just observations, it might be an auger point and it's just observations. Essentially point data. SMAP, so that's my role, that's my responsibility within Manaaki Whenua. That's mapping the spatial pattern of that soil variation across the landscape. The LRI, the Land Resource Inventory, that goes back quite a way in time. Originally it was the national scale inventory, essentially 5 key land attributes: the slope, the soil, the vegetation, parent rock, and the erosion. The next 2 that I'm talking about, both are built on top of the LRI. So the LRI is a series of polygons with those 5 attributes. The LUC is an additional attribute using the same polygons. That is the land use capability, which I'm sure everyone here will be familiar with. It's using 3 of those key properties from the LRI, plus climate, to then classify the overall capability of the land and the erodibility. And the last one, the fundamental soil layers, which is what Graham just mentioned, actually that's based off the LRI polygons. There isn't actually any connection between the SMAP and the fundamental soil layers. And that is 16 attributes that are linked to the soil name that was recorded in the LRI, or the soil series. So just the key differences between some of those things. First is the NSDR is point, the other 4 are all spatial. The LRI mapping was done in the 70s and 80s. The scale and quality of that mapping varies hugely, from the 4 inch to the mile, right up to 1 to 250 thou scale mapping. It's all lower quality than SMAP. It uses that old soil series name, which was really quite subjectively defined, and so there's a lot that's sort of captured in that soil series names. It's hard to tease it apart at a later date, which is why the FSLs are so limited, because they're tied into that soil series name. The FSL is based on categories and predefined classes. Yes, there is a nominal value that is associated with a predefined class. You can go and get the soil depth and it gives you a number. It's just a nominal number that comes directly from the ranges of the predefined classes. And not many people seem to realise that. It's really very limited. What else we got? It's categories. Yep, SMAP started in 2004, a lot more recent, and it's based on national soil correlation. It's much more objective. And so if we have a soil in the Hawke's Bay that's the same as the one in the Canterbury, then we recognise that and call it the same soil. That's where the power is, because it means that where we've got information measurements on the Canterbury soil, we can then apply them to the Hawke's Bay soil as well. So we have quantitative information, or SMAP's got quantitative information per horizon or soil layer, whereas you don't get that with the fundamental soil layers. But the big problem is it's not complete. The LRI and the fundamental soil layers is. So how are we getting on? Progress. The green stuff is where we do have SMAP. The white stuff is where we don't. There's 37% of the country is now mapped. It's about 10 million hectares, but under. 43% in New Zealand is class 7 and 8. So it's a wee bit better than it looks. That class 1 to 4 land, we've now got 67% of it covered. 53% of it is that class 1 to 6 land. Huge range of different soils have been mapped within that, about 5,000 soil types. So why is it so slow? It's because we don't have the funding. It's a real collective, pull a bit of money from there, get a bit of money there, get a bit more money for there, and gradually we're building it up. We've taken the work done by some of those regional growth programs. This is the team for Taupo South. That's one of the core data sets that we've pulled into SMAP. The regional councils have been great. There's a good reason why lots of Canterbury, all of Hawke's Bay, lots of Waikato is mapped. That's because they've funded it. MPI is helping us now, so we do have some funding for the next 4 or 5 years where we are mapping new bits of New Zealand, funded by MPI. Also, that's using this leverage money so that the regional councils are also putting their dollars into that as well. Fertiliser companies have helped us. And in terms of MB, we use the MB money for the science research associated with us, so for the underpinning models, for developing new systems or techniques or research to try and let us do this mapping quicker or better. So here's the SMAP information system. It is an information system, it's not just a database. So just briefly looking at this, we've got different mechanisms of delivering at the top. We have the SMAP online, which hopefully everyone knows about. That's the public-facing, free, here's the data that you can access. We supply some of the data in GIS form to the LRIS portal, which then gets fed into third-party systems. I happen to have put the eCan Farm portal up there, but Ravensdown, for example, also receive that data, as do other companies, and they use it in their systems. And then the third sort of delivery mechanism is via the API or web feature services. Essentially, it's that business-to-business or machine-to-machine transfer of data straight into Overseer in this case. So that's how we deliver it, but the rest of it, the lower part of it, is the core part of the information system. And so in the middle, which I'll talk about in the next slide a wee bit more, that's the bit that's making all the estimates, all the modelling behind SMAP. And it's pulling in the spatial data, the point data, and then our science understanding on how the process is. So just looking at that in a wee bit more detail, this red box is representing that middle inference engine. PTF, that stands for pedo transfer function. It's really around, you've got some easily measured or observed soil properties, but you want to know about these really expensive ones, and it's doing that transfer or that modelling of simple information to the more advanced complex information. And that knowledge comes in all sorts of different shapes and forms, right from the sensors. We can use that data through to the expert knowledge, the heritage data. It might be a rule-based type knowledge model, or an empirical model where we take the point data that we've got with the lab data and devise an empirical relationship, which then means that we can make predictions of other properties. Or it might be a process-based functional horizon, a functional model. So all of that is pulling in the stuff at the bottom and turning it into soil information. Soil water retention, PTF, that's one of the really important ones. This is telling you about the water storage in your soil. So just briefly, that's the saturation, how much water is held, field capacity, after it's had a chance to drain, and then wilting point when the soil is dry as far as the plant is concerned. That relationship is described by the curves on the right. And those curves vary with the different soil types. So we've got quite a complex model that's representing those curves, and that's what you then see at the end as PAW in millimetres in a profile, for example. And that soil water retention information is used really essential for all sorts of different purposes, which I'm sure you're all familiar with, the irrigation, effluent, overseer, catchment models, drought index, and so on. So that's one key important property that comes out of the inference engine, but there are a whole range of other ones. This is just a set of some of the risks that the different soils have in leaching and bypass vulnerability and so on. So that's another output that, or prediction that we can make from SMAP. As I said, the main delivery is via SMAP online, so hopefully you are all familiar. You can zoom in spatially, pick your soil, see what soils are there, what proportion, and then get fact sheets on all of those. Lots of people use it. It's really interesting to see it, but you can see that the Agriservices, they're the biggest group, not surprisingly. But there are also all sorts of other people who are using it for all sorts of weird and wonderful reasons. And the usage is increasing all the time. It's a wee bit out of date, 2019, but when Overseer came in with the FM version, that sort of meant a wee bit of a downdrop, but it's still increasing there. So that's where we are. But what have we been working for in the meantime? Where do we think the need is? And that is, we need to make SMAP more relevant at the farm scale. And there are different ways we can do that. One is to ensure that partners, users of our information, are taking advantage of the best soil science and using the most appropriate soil properties. So I am aware that there are some companies who developed models a long time ago, back in the days of the fundamental soil layer, or even before that, and that's all their models are based on. Whereas in fact, there are a whole lot more new properties that would be more appropriate for their given use. So we want to work with partners to make sure they are using the best science. And that may mean that we need to develop new pedotransfer functions to do new properties that are relevant for any particular model or use case. I think there's a real need in more interpreters and translators. We're quite good at doing that technical information, but I'm not sure that we've translated that well for farmers so they can pick it up and understand what it means to them in their management of their farm. I would like to see those, in the old days it would have been done by the soil experts going out on the farm advisors, but we don't have that anymore. We need to get our systems to replicate that. Data supply via APIs is much better. That's got to be the way of the future. We've talked about it. It's feeding our data straight into your model so that you don't have to manually enter it or enter it multiple times. Smart model. So what this means is one of the problems we have is that we can't get across all of New Zealand. There's only a certain amount that our soil surveyors can do. Whereas you guys, the farmers, are out on the land, and so you can collect some of this information, but you don't have easy access to what we have, and it's the merger of the two that can really add value, whereas we've got the inference engine, we understand what it means, we can do the modelling of the soil information, if you can provide a bit of extra information into that. And so it's these integrated, what we call smart models, or effectively a web processing service where you provide a bit of the data, we provide some more, together we can provide you more information that is useful. And ideally, that then feeds straight into the tools that you need it to be used in. And the last one is the access to the new sensing technology and models. This is to be able to get those cost-effective means of getting access to these expensive properties. So this, very, very quickly, is sensor technology, proximal sensing, where you go out, you do a sampling design in your paddock, go and get some cores, send them off to the laboratory, get them scanned, that turns them into spectra, so it's a digital representation of that core, run it through our models and our equations. We can then give predictions of the soil properties, I've got them listed over there, which can then be turned into the information that Overseer needs and with the various representations of that data to make it useful for you. So we see this as being really important, really it's the way of collecting cost-effectively information that you need on your farms to tell you about your your soils and your land. And the very last thing, way beyond, that we're not yet working on, is ideally that information that you're collecting, especially the spectral stuff, if that can then feed back into SMAP so that we can then make a better SMAP. So that's sort of further out in the future. So that's where we see SMAP at the moment and where we're heading, and we would really like to head in the future.
Excellent.
So I guess, stand in front of the microphone, just a few reflections on the day, and I'll keep this brief. So the first thing I thought about was the messages from our practitioners in the morning sessions. So the people, the farmers and the people who are working closely with farmers. And they talked about, unashamedly stolen from your slides, folks, people, planet, performance, and I've just kind of expanded those out a bit more. We talked about the importance of people, and I think we've reflected on that during the day. There were questions about what's stopping data interoperability, and the answer was people. There were questions about how do we get adoption, and we talked about the need for specialists, and so a lot of it comes back to the importance of people in our thinking. Mathematical equations are great, but people are very important. Planet, we've talked about the need to make sure that we're farming within the constraints that we've got and doing the right things for our land and our planet. Performance, and I've added, and productivity there, and Martin's questions are good ones. We want to include, we know we often fall into talking about improving production, right? And we know we don't want to talk about improving production, we want to talk about improving productivity. The measure of what we're getting out, and the bottom line measure of that is profit, as long as the other factors are equal for the amount of inputs put in and for the amount of emissions going out. Then something that I got out of those farmers who talked this morning is their strong emphasis on planning, on the processes that they and their teams follow, the communication of those processes, and the precision with which they go and measure. They identify what are the important things for them to measure in their systems, and they go and measure them. And together that, that was talked about as systematisation, turning things into a system that's repeatable, and I think that's key. So some great learnings for me in those areas today. We talked, for those who are involved in research and in governance, we talked about capabilities. And I guess my reflection, thinking about some of the presentations, was the amount of amazing capability that we've had leveraged in this sector over many years in our science R&D and all of the things that underpin that. Some fantastic capability. And I think that goes to the heart of what you were talking about before, Graham. Other countries are investing in their core competencies, and in New Zealand we've made a lot of investment, not enough, but a lot of investment in building capability in pastoral agriculture and its underpinnings, which has been fantastic. There's some really valuable collections. We talked about the virtual climate stations, we talked about SMAPs, and we've talked about some of the other collections that are out there. I didn't want to just say databases because there's a lot more than just databases. Almost every speaker talked about the opportunity to collaborate further, to engage further, to use data from other sources, whether that's climate stations or soils data or any of the other data sets that are potential to use, and the opportunity to engage together. And we see that in some of the collaborative projects that have been done. We talked a little bit about data integration, and to me there's some real benefits in being able to link data and to have common identifiers and all of those necessary things that make it easier to connect the dots between systems, and also consistency in meaning and interpretation, and are we talking about the same things? And then this afternoon we talked about our, and I'm playing some fun games here, but we talked a little bit about sensing. We started off by talking from space, which is very much built on sensing technologies. But I thought, particularly when I was listening to Dean as well, that's another great example of sourcing data so that farmers aren't having to go and measure it. You know, imagine if you as a farmer, and farmers did have to do this, some still do, go and attend every sale yard that they can so that they know what the prices are. Try and keep their own little book so that they know, you know, where prices are heading. But there are tools that can deliver that data just as space can deliver pasture cover data. And I think we saw through the work that Ravensdown and Balance are doing a bunch of other sensing and use of predictive tools to take some of the effort that farmers would have out of sort of capturing data and making sense of it. A lot of the tools we looked at, including FarmMax and including the tools that Ravensdown and Balance have been working on, have been around making predictions that help people make either recommendations or decisions, and that's really powerful. And I think there's been some, again, a thread of discussion going through around, well, how do we then extend those services out? If you've got other crops you want to measure with space, how do you do that? Can we extend those services? If you've got some data that's in FarmMax or one of these other tools, how do we make it available? How do we make data flow into FarmMax? I think my other observation is that we're still at the stage where many of these tools, maybe space being an exception here, require the assistance of somebody, a specialist, to help interpret them, right? Whether that's a rep or an agri manager in a fertiliser company, and we know there's good reasons why we should be doing that, or a consultant to help you with FarmMax. And I'm not saying, you know, we know those roles are essential and important, but if we're to move to support for adoption and use, we need to think about how we kind of leverage the time of those people, right? So that they're doing the things that only they can do, and that our tools and our systems are easier to use so that specialists don't have to get involved at every step in the way. So I guess that's my kind of reflections on what we've talked about today. I hope that, like me, this has been of interest to you, that you've had your eyes opened to some interesting things that people have been doing and some opportunities. I think it's been great to have the input from the farmers and the practitioners to kind of ground truth what the problems are that we're trying to solve. And what we're hoping is that this conversation continues on. So if you're on Zoom or if you're here in the room, hopefully you've made some contacts or you've made some notes of people you should talk to, and we'd really encourage you to continue to do that. If there's any way that Rezare can facilitate those discussions for you, we're happy to do that as well. So thank you very much.